In this video, we'll be determining the spontaneity of a reaction by using the Gibbs free energy equation. So here I've laid out the equation, which is 1 mole of methane plus 2 moles of oxygen yields 1 mole of carbon dioxide plus 2 moles of water. First, we'll start out by writing the Gibbs free energy equation, which is change in G equals the change in enthalpy for the entire reaction minus the temperature at which the reaction is occurring times the change in entropy of the reaction. So first we're going to start with the change in enthalpy of the reaction. I already calculated this by using the enthalpy of formations in the back of the book. I took the sum of the enthalpy of formation for the products and subtracted the sum of the enthalpy of formation for the reaction, or for the reactants, and I came up with the enthalpy of the standard reaction equals negative 890.3 kilojoules. You probably already know how to do that. That's why I didn't write it out in this equation, so we're going to be putting that here. But first, we need to find the change in entropy. To do this, you need the standard change in entropy of formation per mole of each of the products and reactants. And this is in the same table as the enthalpy of formation is. So I already wrote down the entropy per mole of reactants and products right here, right under the equation. And so we'll start out by calculating the change in entropy, just like you calculate the change in enthalpy, by subtracting the sum of the products minus the sum of the reactants. So the change in entropy equals 213.6 joules per Kelvin mole minus 2 times 69.9 joules per Kelvin mole. I multiplied this value by 2 because there are 2 moles of water in the products. Because this is the standard value for the entropy of formation per mole, so I have to multiply it by 2 if there's 2 moles in the products. So that's the equation for the products. Now the reactants is 186 joules per Kelvin mole plus, that's actually supposed to be a plus up there because it's the sum, plus 2 times 205 joules per Kelvin mole. So I did the same thing in the reactants. I multiplied that by 2 because there are 2 moles of the oxygen in the reactants. So let's do this equation. Let's grab my calculator real quick. 213.6 plus 2 times 69.9. It's 353.4. So 353.4 kilojoules, or sorry, that's joules per Kelvin mole. And the reactants, 186 plus 2 times 205 equals 596. So we are going to subtract the value for the products minus the value for the reactants, and that will equal 353.4 minus 596, negative 242.6. So that's the value for the change in entropy. So let's write it down here. Change in entropy equals negative 242.6. So let's see what this means. You can see just by using common sense in the reaction, the products involve more order than the reactants. This is because 3 moles of gas yields 1 mole of gas plus 2 moles of liquid. So you could assume because there is less entropy in the products than there is in the reactants, that the total entropy will be negative. And this equation right here proves that we were correct. And we look at the enthalpy of the reaction, which I wrote right here. Because it's negative, this reaction is exothermic. So let's write out this equation. The change in G equals the change in enthalpy minus temperature at which the reaction is occurring, multiplied by change in entropy, which we just found. Let's put in our values. I'm going to take this value and put it down here. So change in G equals negative 890.3 kilojoules. Now this is where units become important. Because we have kilojoules for the change in enthalpy, we have to maintain kilojoules. And because the change in entropy is in joules per Kelvin mole, we need to divide that by 1,000 to create a number that will work in this equation. So you multiply that by 1 kilojoule in 1,000 joules, and you get negative 0.2426. So that's the value we're going to use. So minus whatever t is going to be times negative 0.2426. Now t, because we used the entropy of formation in standard temperature per mole, standard temperature is 298 Kelvin. 298 Kelvin is equal to 25 degrees Celsius. To go from Celsius to Kelvin, you just add 273 degrees and you end up with Kelvin. So we're going to use that number, 298 degrees Kelvin. It's actually just 298 Kelvin. So 298 K. Alright, now whatever we get for the answer of this will determine the spontaneity. If this entire reaction is less than 0, we have a spontaneous. If it's greater than 0, it's non-spontaneous. So let's see what we get. Negative 890.3 kilojoules minus, let's see, 298 times negative 0.2426. The result is negative 72.29 minus negative 72.29. So this answer, let's rewrite it, plus 72.29. Let's not forget our units, kilojoules per Kelvin mole. So this is obviously going to be a negative number. So change in G is less than 0. So this means the reaction is spontaneous. And that's it.